Okay, so hello everyone. Today we're gonna explain actually the project predicting temperature in London. Okay, my name is Mohammed Nasif Zouawi and I'm from Computer Engineering Department. Okay, unfortunately because we don't have a lot of time, so we're gonna shorten as much as possible. Okay, but we will try to cover the necessary keys. Okay, I'm gonna provide 5 minutes for explanation and implementation and 5 minutes for output and discussions. Okay, so let's start. Okay, so as an abstract, okay, we're gonna see what is the project about. Okay, this project aims to predict mean temperature using various regression models based on historical weather data from London from the year 1980 to 2020. Okay, so basically there's a data set that it covers like temperature, precipitation. It has a data set. It has all the informations of temperature from the year in days, months, years, from this year to this year. Okay, we can see the beginning and the ending. Okay, now we're gonna start with implementation and explanation. Okay, we can see this is the full code. Okay, we're gonna divide it into blocks. Okay, and in these blocks we're gonna explain in details, maybe not in details, but we're gonna see functions, what's the role of it, okay, and etc. Okay, so first we're gonna see this is the full code of the solution and implementation. We will divide it to blocks, and in the next slides we're gonna see what's going on. Okay, so this is implementation steps. First of all, we're gonna import libraries. What is libraries? Libraries that will contain all the functions we're gonna need, okay, for our model, like pandas and numpy. This is for data manipulation and also for data reading. Pandas, for example, if you have a data set in our computer or in our HDD or I don't know, okay, and we're gonna implement it in Python. How? We use pandas, MLflow for tracking experiment, and we're gonna see this later. Okay, this is quite important. Matplotlib and Seaborn are common libraries used for visualization, and we're gonna make figures with it. And scikit-learn that has all the algorithm for machine learning. We're gonna choose some and we're gonna work on it. Okay, so next step, we're gonna load data and exploratory it, and we're gonna analyze it also, and we're gonna see something called cleaning, and of course it's divided here. So using the panda library, we are writing a code in order to be read and uploaded, and also we are cleaning it using info command. Okay, so for example, this one, as we told before, PD, this is from panda, and read CV, this is the name of the dataset given, and info, it's gonna provide some informations, and we're gonna use it to clean the dataset if it has like some missed values or something. Okay, now this part here used to convert data, extract it from year to month. Okay, so like as we see here, this is the treatment of it. Okay, and these two lines are used for aggregating data, calculating average metrics per month. Of course, we're gonna perform some calculations. We need to see what's going on. Okay, here for example we are calculating the mean. As we see, okay, we can calculate the average, we can calculate whatever, the median, not the mean, okay, according to our objective. Okay, and this one used to visualize. This part used to visualize data using matplotlib and PLT show according to the matrix we made. We're gonna see later what does mean matrix. Okay, now this is step 3. Step 3 is used for data preparation. We're gonna prepare data to be trained. Okay, trained, what does mean trained? We're gonna see, of course. So here, this is our parameters for given by the dataset. Okay, this is the calculation will be made on this thing. Okay, but this here, it's like a feature. We're gonna choose some targets to focus on, and we're gonna see what's going on at that time exactly for each one of these. Okay, so in this step we will start doing something called data modification. So we will start by selecting features like month, cloud cover, and sunshine, etc. These are okay, and we can add more if you want. And the target, which is the mean value, we can also change according to our objectives. Again, as I said before, okay, this is the parameter we're gonna use as a target value. We're gonna work on. Okay, we're gonna change it if you want. Okay, so these are the lines Okay, in this one we're gonna see something called splitting data using the first line, and for the last three lines we are doing something called imputing or missing data. And these steps used for organizing the data received in order to obtain good, or we can say optimized results. Okay, for example, if we're gonna analyze some data or a given data set that has millions or tons of information, we need to organize it well to be readable, optimized, well optimized, remarkable, we can analyze easily, everyone can read it, etc. Okay, so the first one is used for splitting. Okay, for example, if we have confused data or how can I say, mixed data, okay, we can do something like this. Okay, and according to these numbers we're gonna split it according to these numbers. Okay, so, and we're gonna see what does it mean scaling. Okay, okay, next one is scalar, this one. Now we will scale it. This is for the data set that we will obtain, and also for the output we will obtain in terms of a figure, and it's done because we want to see something, an output, while scaling according to the picture dimensions. Of course, if we're gonna see a picture of, I don't know, picture like this, we're not gonna see something like every millimeters, or we're gonna find something. Of course, this is not readable, it's not easy to analyze. Okay, so we're gonna make something well readable and well analyzed in order to be executed for everyone. Okay, so next step is called model training and evolution. Okay, what is training exactly? Let's assume we have a child and we wanna train him to do something. Okay, so we're gonna give him tasks to do. Task 1, task 2, task 3, task 4. If he finish 1, he moves to 2. If he finish 2, we move to 3. Okay, so task 1 and task 2 and task 3, these are successively done. So if he didn't finish the task 1, he will not move to the next one. Okay, this is what we're gonna do. We will divide this loops. This is a loop actually, beginning with this pick. This is called model training. It means we will give the model data and we'll try to make him learn what he needs to do throughout the guidelines we'll apply in the next steps. So these three lines, using ML flow to keep track of model version parameters, and this is called log flow. For example, we're gonna let's get back to the child example. If we're gonna give him some tasks, of course we should watch him what he's doing. Okay, this is exactly the same. We're gonna check and we're gonna validate. Okay, achieve it through the parameters. These are the parameters given, which is the pink color, and we will see later in the results. Okay, now this one, at this step we will see something called model I'm sorry, this is a mistake, model evolution. Through some checks done, we will validate if the model performs as we want him to know, as we want him or no, or at least it can do the majority of tasks. Of course, let's get back to the child again. If we're gonna give him the tasks, we're gonna check if he performs it well, or if he does the primary functions. Okay, and now at these lines we will see something called log matrix, and it means that in each step or subtask the model performed, we keep track of results. What does it mean this? And we record it. For example, the child, when he does something, we're gonna just say, oh, he did this, he did that, he did that. So after the work finish, we'll analyze how this child performed. Exactly, this is the same. In this model, we're gonna pick some parameters to keep track with. Okay, and this one we're gonna visualize it, and we will see what's going on. We'll obtain some figures. Okay, and we will discuss in the output and discussions. Okay, first we obtain picks and dataset as an output, and we will try to analyze them one by one, providing some conclusions and most remarkable variations. Okay, now as we see, according to Matplotlib and the code we run, we obtain this output and this one and this one. Okay, we're gonna start one by one. As we see, the y-axis contains the mean temp according to the years. We can see that from this year to this year, it's like increasing. Okay, we can see that when we run the code, we obtain this figure primarily, and the line graph we provided, I don't know why I said you provided, okay, shows the mean temperature in London, England, over several years. Overall trend. Okay, what does it mean overall trend? We're gonna see from here to here how the graph evolved. Okay, The graph shows a general upward trend in mean temperature over time. This suggests that the climate in London has been gradually warming. Yearly variability. Despite the overall trend, there are fluctuations from year to year. These variations could be done due to seasonal changes. It happens even in our time today. So, natural climate cycles or other factors. Other factors like, how can I say, climate change, not climate change, what is it? I forgot it. When the climate change in the poles, like the South Pole and the North Pole, are beginning to vanish. Okay, I forgot that phenomenon, but it has a big impact. Starting point from this one, around 1980, the mean temperature was approximately 10.5. It's nearly nothing. Okay, we can say that it's not nearly nothing, but when we started, it's not too much. Okay, and in the ending point just before 2020, the mean temperature had increased to around 12.5, so it increased by 2.5 Celsius. Okay, implications. The increasing mean temperature could have implications for various aspects of life, including agriculture, energy consumption, and public health. That's why we always should take care of pollutions, and we must always take care of ourselves in terms of heat. And it's gonna, like, the rivers and seas are beginning to vanish. Okay, so we should really take care of this thing. And this is the other one. Okay, this is the matrix. Okay, this is called confusion matrix. Okay, this is done by machine learning algorithm. Now for the second pick, we can see that the heat map provides a visual representation of correlation coefficient between various weather related variables of the months of the year. Okay, we can see that there are months, 12 and these are the targets we choose and features, if you remember. Okay, strong positive correlation variable like max temp, mean temp, and min temp shows strong positive correlation with each other, indicating that this one increase, the other one that increases too well. So, what does mean correlation? It means the relation. If this one increase, this one also increase. Okay, so seasonal patterns. Certain variables exhibit seasonal patterns with different correlation across the months. For example, sunshine may have stronger positive correlation with temperature variables during summer months. Of course, and this is natural because the day becomes longer. Okay, negative correlations. Some variables such as precipitation and snow depth might show that negative correlation with temperature variables, suggesting that higher temperatures are associated with less snow and precipitation. For example, when the temperature in crossing the history or years increases, the other one decreases. And this is natural, of course. Data interpretation. This is like interpretation as the whole figure, as it highlights. This heat map can guide the selection of the features for our machine learning model, as it highlights the relationship between different predictors and the target variables. Okay, that's it. Sorry. I'm sorry. Okay, so this is for the given data set. This is output. Also, we obtained this dataset and it has all the information needed that we requested before, the log matrix and the tracking and all the operations we wanted in one dataset. Okay, as we see before, matrix, parameters, max depth. Okay, start time, end time. Okay, these are calculations we made using some functions. Experiment tracking. Each row represents an individual experiment with a unique run ID. When you remember, we are recording what's happening. Okay, experiment ID, experiment ID, experiment ID. Okay, these are zeros. I don't know exactly what is zeros. It should be like 1 or something. Oh, no, I'm sorry. These are the IDs we should take care of because it's the same experience with different times. So I'm sorry. Yeah, that's it. Performance metrics, key metrics like mean, absolute error, MAA. Okay, it's in this side, so we should scroll it. Okay, root mean square errors, RMCA, and R2 score are included to evaluate model performance. This is these ones we said. Okay, this one RMCA. Okay, RMCA. Okay, that's it. And last but not least, model parameters. Columns like params, max, def indicate the hyper parameters used for each experiment. Okay, now thank you for listening, and honestly, it was a good project. Okay, for us. Thanks a lot. Have a good bye.